Questions 21 through 25 on the 2013 Grade 11 Fermat Math Contest. A farmer has a rectangular field with width 45 meters. He divides the field into smaller rectangular animal enclosures in 3 different sizes as shown. Each enclosure labeled A1 has the same dimensions. Also, the area of the enclosure labeled A2 is 4 times the area of A1, and the area of enclosure labeled A3 is 5 times the area of A1. The lines in the diagram represent fences. The total length of all the fences is 360 meters. The area of A1 in square meters is closest to. Let's label this X, X, and X, and then this will also be X, those little guys, like that, and then this side will be 3X from here to here. And then we will label these side parts Z and Z, but this part I don't know yet, because that's not going to be Z. And then therefore, this is going to be Z, and that's going to be Z. This part from here to here I will call Y. And this part, of course, is also Y. And then this part I don't know yet, because I have to first concentrate on figuring out that. Okay, well, we'll just call that W for now, for W for width. And let's take a look at our first piece of information, which is that A2 is equal to 4 times A1, given to us in the question. Well, A1 in terms of its area will be X times Z, and A2 in terms of its area is 3X times W, correct? So the X's cancel from both sides. You're just left with 3W is equal to 4Z, and therefore W is equal to 4Z over 3. So put that in here, 4Z over 3. So if I add all these guys up, it'll be Z plus 4Z over 3. And if you add that up, you will get a sum of 10Z over 3. So this top to bottom is 10Z over 3. So there we go. And I think that's pretty much all the dimensions for now, just with A1 and A2. So now we will concentrate on the next piece of information, which is A3 and A1. They tell me that A3 is 5 times the area of A1. Okay? Well, what is A3? In terms of our dimensions, it would be Y times 10Z over 3. And 5A1, well, that's just XZ as before. Okay, let's see how far we can go. The Z's cancel from both sides, so we're just left with Y is equal to 10 over 3 is equal to 5X. And then Y, therefore, would be 15 over 10X. And therefore, Y will be 1.5X. Like that. All right, so that's a pretty good start. Now, where do we go from here? Well, now what we have to do is take into consideration the whole business about the fence. That fence is equal to 360 meters. And we also can take into consideration that 45 up there that they gave us. So from the 45, that means that 3x plus y is 45. And that's a pretty helpful piece of information, because now we can substitute this into that equation I just drew. So that's going to be 3x plus 1.5x is equal to 45. So that means 4.5x is equal to 45. Therefore, x is 10. And therefore, if x is 10, I can substitute that in here. Therefore, y will be 1.5 times 10, which is 15. All right, great. And now we have to figure out z. How we figure out z is by using, of course, this part, that the total fence is 360. So we have to now figure out what is the total fence. Okay, first let's concentrate on the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 3, 12 x's make up part of that fence, so we have 12x. Now let's concentrate on the z's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got 8 z's. And then I've got these two guys here that were 4z over 3. So 2 of those guys. So 2 times 4z over 3. And then I've got 2 y's, and then I've got this 10z over 3. So plus 2y plus 10z over 3. And all of that is equal to 360. Okay, so I think I can figure this out. Let's just do this basic algebra. Well, we can substitute in these guys. That will be very helpful for us. So that will be 12 times 10, which is 120. 8z, well, z I don't know. This is 8z over 3. 2y, that's going to be 2 times 15, so 30. 10z over 3, and then that's 360. So let's add these here. We got 18z over 3. Well, that's just 6z. So 8z plus 6z, and then put all the numbers on one side. 240, 210 is going to be that number. So I've got 14z is 210, and therefore z is 15. Yeah. All right, let's figure out now the final thing, which is the area of A1. The area of A1, that's our final task, is x times z. Well, x is 15. Z we figured out to also be, x is 10. And z we figured out to be 15. So therefore 10 times 15 is 150. And that's the answer. So number 21, the answer is B. Megan and Shayna race each other, with the winner of each race receiving X gold coins and the loser receiving Y gold coins. There are no ties, and X and Y are integers with X greater than Y greater than 0. After several races, Megan has 42 coins and Shayna has 35 coins. Shayna has won exactly 2 races. What is the value of X? All right. Megan and Shayna. So Shayna has won exactly 2 races. So when she does, she receives X coins and then X coins for the first win, for the second win. During those games or matches, races I should say, Megan is going to get Y coins because she lost those 2. But then of course there's going to be a whole bunch of wins for Megan. I don't know how many. XX ... And then for each of those, matching losses for Shayna ... Y, because she's going to get Y coins for losses. Now the number here that I don't know, I'll call it N. So this is obviously 2, and then these guys are N. Okay, and then this total, 2y plus nx is 45, or 42 actually. Yeah, 42 coins. And then over on Shayna's side, 2x plus ny is equal to 35. All right. So that's what we have to work with here. So here we go. We have 2y plus nx is 42. We'll call that equation 1. And my equation 2 is 2x plus ny is equal to 35. Well, we have to do some manipulation. 1 minus 2 probably will help us, I hope. That's going to be 2y plus nx minus 2x minus ny is equal to 7. Let's do some factoring here. Let's see here. If I factor in x, I will get n minus 2. If I factor out a minus y, or let's see here. Yeah, minus y, that'll work. That will give me a n minus 2. Yeah, okay, that's great. So n minus 2, and then times x minus y. All right, works out perfectly. Factor is great. Okay, so now we've got this situation. We've got 3 variables in one equation. So obviously I've got to use some inspection here. So either this is 7 and this is 1. That's the only way that would work. Or this is 1 and this is 7. Right? because this multiplied by this has to equal 7, and 7 is prime. So those are the only two ways I can get it to be prime. All right, so let's work with those two scenarios. So I've got two scenarios. The first one is when n minus 2 is equal to 7 and x minus y is equal to 1. If n minus 2 is equal to 7, that means n is 9, and therefore x is equal to 1 plus y. Yeah. All right, let's plug it back into the other equations up here to see if we get any kind of valid values for x and y. Equation number 1, let's use that. Why not? That's going to give me 2y plus 9x, which is 1 plus y, is equal to 42. So that means 2y plus 9y is 42. That means 11y is 33, and therefore y is equal to 3. If y is 3, x is 1 plus y, so x is 4. Okay, that's pretty valid, and x equals 4 is one of the answer choices. But I'm pretty sure that's the answer, but let's just do the other one. The other scenario was when n minus 2 is equal to 1 and x minus y is equal to 7. If n minus 2 is equal to 1, that means n is 3, and this will be x is equal to 7 plus y. Again, let's substitute it back into there to see what answers we get. It'd be 2y plus 3x, which is 7 plus y, is equal to 42. 2y plus 21 plus 3y is 42. 5y is equal to 21, and therefore y is equal to 21 over 5. Well, that's not an integer. X and y have to be integers, right? Because they represent a certain number of coins. They even say that in the question. All right, that means this scenario is no good. This is the only scenario that gives us the valid integer values. Yep, so x is 4. And therefore, number 22, the answer is E. One bag contains 2 red marbles and 2 blue marbles. A second bag contains 2 red marbles, 2 blue marbles, and G green marbles with G greater than 0. For each bag, Maria calculates the probability of randomly drawing 2 marbles of the same color in 2 draws from the bag without replacement. If these 2 probabilities are equal, then the value of G is. Well, here we go. We've got 2 red and we have 2 blue. Now, the probability of choosing 2 of the same color, first let's talk about what happens if you want 2 blue. Well, for the first selection, you would be choosing 2 out of 4. That's the probability of getting 1 blue. Then once that first blue is gone, the second blue can occur with a probability of 1 over 3, because it'd be this from these 3. So multiply them, and that is 2 over 12. Now we want to calculate the probability of 2 red. 2 red, same thing actually. The first selection can be red with a probability of 2 over 4, and then the second one can be red with a probability of 1 over 3, so that's 2 over 12. Then you add these guys, you get 4 over 12, which is equal to 1 over 3. That is that probability. Now, what they want you to do is figure out the same sort of story, but this time we've got 2 blue, we have 2 red, and then we have a whole bunch of greens. Now, the number of greens, they don't tell me. They just tell me that it's G, ... and that this is G. Okay, well, this is obviously 2, and that's 2, and this is G. But the way you'd calculate the probability is pretty much the same. So first, let's talk about 2B, 2R, and then 2G. Okay, so the probability of getting a B, a blue, is 2 over 2 plus 2 plus G. That's the total. For the second selection, it would be 1 over 2 plus 1 plus G. So this is basically 2 over 4 plus G times 3 plus g. All right, no tricks, just straight, exactly the way I did it for the first one. For the 2r, it's the same story, 2 over 2 plus g times 1 over 2 plus 1 plus g, and it comes out to be exactly the same, 4 plus g times 3 plus g. Now 2g, the probability of getting green for the first selection is g over 2 plus 2 plus g. The probability of getting a green for the second selection, now it's g minus 1 over 2 plus 2 plus g minus 1. So that is g times g minus 1 over 4 plus g times 3 plus g, like that. And now, as before, we have to add up this guy, and this guy. And when you do, you get the following. You get all the denominators are the same, so it would be 2 plus g times g minus 1 all over 4 plus g times 3 plus g. And that, they're saying in the question, is equal to the probability of the first scenario, which is right here, 1/3. And there we go. That's the equation you're going to use to solve for g. So let's do that. Cross multiply, you get 4 plus g times 3 plus g. Cross multiply and you get 3 times 4 plus g squared minus g. This is going to be 12 plus 4g plus 3g plus g squared. This is 12 plus 3g squared minus 3g. The 12s cancel. Let's put everything on one side. 2g squared minus 3 minus 7, so minus 10g equals 0. Factor out a 2g and give me g minus 5. And this tells me that g is equal to 0 or 5. The question told me that g is greater than 0, and therefore g must be equal to 5. So, number 23, the answer is 5, which is choice B. In the diagram, the triangle PQR has S on PR and V on RQ. Segments QS and PV intersect at T. Segments RT and SV intersect at U. If the area of RST is 55, the area of RTV is 66, and the area of RSV is 77, then the area of PQU is. Here is our diagram, but initially I will use a diagram that does not have P, U, and Q, U in it, and then at the end we'll bring those two lines back. The first thing I'd like to talk about in this question before we even begin is a concept that is going to be used again and again in this question, and that concept is as follows. Let's say you have a triangle, and we'll label it. So we have A, B, and C. And then what I do is I drop a line from A down to that base, and I connect that and call it D. And then I say, I want you to compare ABD, that triangle, to ADC. Well, since these two triangles have the same altitude, if you draw a line from A down, that represents the height for both of those triangles. So when that is the case, the areas are as follows. ABD is 1/2 base times height. The base is BD. The height is this H. The area of ADC is 1/2 base times height. The base is DC. And the height, again, is H. So this just simplifies to just BD over DC. The halves and the H's cancel. So repeatedly in this question, we will use this concept that whenever you have two triangles that would have the same height, the ratio of their areas is the ratio of their bases. All right, so that is the first part of this question. Now we get to part 2. In part 2, we're going to start talking about the triangles that they mention in the question. They mention RST, they say is 55. They also mention RSV, RSV, which is 77, and they mention RTV, which they say is 66. Okay? Well, let's say that we have to compare these triangles. So this is what we're going to do. First, we're going to look at RSU, and RSU is this triangle right here. That one is equal to RST minus SUT, correct? Well, RST I know is 55. RST is 55, but SUT I don't know, so I'm going to introduce a variable. I'm going to start calling these with the letter A. So SUT I will call A. So I've got 55 minus A. So that's RSU. All right, let's do something similar for RSV. RUV. RUV is right here. That is the same as RSV minus RSU. Well, RSV is 77. RSU, I just figured out, was 55 minus A. So that means RUV is 22 plus A. So RUV is 22 plus A. All right. And in a very similar way, we continue. We have RTV. We want to use that. So that's probably going to be used with TUV. TUV, this one, which is essentially RTV minus RUV, like that. And RTV, they have told me in the question it is 66. And then RUV is 22 plus A. So it's 66 minus 22 plus A. And that basically is 44 minus A. All right, so we'll put that in here. That was TUV, right? So this guy in here, 44 minus A. All right, so we have one more similar comparison, and that's going to be as follows. Before I get to that, let me just complete this. RSU was 55 minus A, so let me just put that in there. Okay, now we can get to the next part. Now, I want to figure out what is the value of A here. I've got it labeled, and I've got all these triangles in terms of A, but I would like to know the value of A. And that's where we start utilizing this rule right here. And we'll do it initially on SUT, that triangle, and RSU. SUT is right here, and RSU is right here. As you can see, it's a very similar situation to here. They have the base that's connecting them, but they will have the same height. So therefore, the ratio of the areas of the triangle will be the ratio of the bases, which will be UT over RU. Okay? But the same relationship holds true for two more triangles, that is TUV and RUV. As you can see, TUV is here and RUV is here. So they will also have the same principle that the ratio of their areas is equal to the ratio of those bases. All right, let's start plugging in our values. SUT is 55 minus A. RSU is, SUT was A. RSU was 55 minus A. And then on the other side, TUV, that's 44 minus A. And then RUV is 22 plus A. So as you can see, we've got a really nice way of figuring out A now. Cross multiply, you get 22A plus A squared. On the other side, you get 55 times 44 minus 55A minus 44A plus A squared. Okay, so the A squareds will go on both sides, and all you're going to be left with is 55 times 44. And then if you bring all the like terms over it will be 99 plus 22, so that's 121a. And then when you divide through by 121, you will get a is equal to 20. So that is very helpful, and that will allow us now to fill in these values. So let's do that. Let's proceed. Well, now that I know a is 20, I can fill in my values. This one was 55 minus a, so that's going to be 35. This one was just a, so that's going to be 20. This one was 44 minus a, so that's going to be 24. And this one, 22 plus a, will be 42. All right, so I've got numerical values for those. So we've made some very good progress so far. Okay, now we move into step number 3, and that is looking at a few more triangles now in the same diagram. And this time it's PST and RST. And those two bases will be PS and RS. But those two bases also belong to two more triangles. They belong to PSV and RSV. Correct? So we can now use these. What I'm going to do is, just as before, introduce some variables. This triangle I'll call C and D for their areas. So PST is C, RST will be 35 plus 20, which is 55. And then going over on this side, PSV, that's going to be actually 44 plus C. And then RSV, that's going to be 77. All right, so this will allow me to figure out the value for C. If I cross multiply, I get 77C is equal to 55 times 44 plus 55C, and therefore 22C will be 55 times 44, and therefore C, if you do the math, will be 110. All right, so now let's figure out this ratio here. PS over RS is the equivalent of this guy or this guy, either one. If I put C over 55, it would be 110 over 55, and that is equal to 2. So that ratio of 2 is going to help us later on in the question. Now, in a very similar way, let's move this up. We want to do the same kind of thing, but this time on another triangle. That other triangle, in terms of its relationship, will be QTV and RTV. You'll see that those two share a base, and the ratio of those sides is QV over VR. So it's the same principle used over and over. QV and VR also belong to SVQ and SVR. So let's sub in the values. QTV is D, RTV is 42 plus 24, so that's 66. And then looking at these ones, SVQ is going to be 44 plus D, and SVR will be 35 plus 42, that's 77. Okay, same story. Let's cross multiply. 66 times 44, and then plus 66D. So that's going to be 11D is equal to 66 times 44. And when you solve for D, you get a value of 264. And very similarly, I'd like to know what is the value of that. QV over VR. Well, I can use either one of these. D over 66, 264 over 66, and that is equal to 4 for QV over VR. Okay, all right, so that is going to help. Now we are into the fourth of 5 steps in this challenging question. Again, we're going to go back to that same principle and look at a few more triangles, this time PTQ and PST. And those bases are TQ and ST. But 2 other triangles share the same bases, namely QTV and STV. Now PTQ, we have to now look at this and say, well, I don't know what PTQ is actually. I haven't labeled, haven't figured out any value. So that's obviously what we're going to figure out. PST, well, that's C, and we had previously calculated C to be 110. And that's going to be QTV. Well, QTV was D, and we had previously calculated D to be 264. And then STV, well, that's going to be 20 plus 24, which is 44. So there we go. This can easily be calculated. PTQ, therefore, when you do, becomes 660. All right, great. We are now down to the final step. So the final step has to look at something that we sort of avoided so far, which is PQU. We didn't even write in the lines, but let's do those lines now. So those green lines represent PU and UQ. Now PQU, how do we figure that out? Well, you have to look at it from the perspective that it's going to be PTQ plus PST plus QTV plus STV, and then you have to subtract from that PSU and QVU. So let's just draw it out. PTQ, this is PTQ. And then PST, this is PST. QTV, this guy. Then STV. And then from this whole monster, we have to now take away PSU, which is this here, and QVU, which is this one here. If we do, we get left with PQU. So that's basically our strategy. Okay, let's see if we have a lot of these. PTQ, I just figured out was 660. Okay, great. PST, that's 110. That's already been figured out. QTV, that's 264. STV is 44. It's 20 plus 24. Okay. PSU. Okay, that I have not figured out yet. And then QVU, yeah, that I have not figured out yet. Okay, so we have to now concentrate on getting those two. Once we do, we'll be done. Okay, so PSU, that over RSU is the same as PS over SR. Okay, if you look at those two triangles. But PS over SR, we have calculated up here to be equal to 2. So I just plug it in there, 2. So that means PSU is equal to 2 times RSU. And RSU is 35. So this is 2 times 35, which is 70. So PSU is 70. So 70 goes in here. In a very similar way, let's figure out QVU. QVU over RVU. That's going to help me. QVU over RVU, if you look at those two and you look at their bases, the bases are VQ over VR. Well, VQ over VR, I had figured out was 4. So that means QVU is 4 times RVU. And RVU is 42. So 4 times 42, and that is 168 for QVU. So there we go, 168 goes in there. And when you crunch out all these numbers, 660, 110, 264, 44, minus 70, minus 168, you get a final answer of 840. And that is the answer. 840 is choice C for number 24. For how many odd integers k between 0 and 100 does the equation have exactly 2 pairs of positive integers mn that are solutions? We have an equation, and I'm going to make a few substitutions to make this a bit digestible. The first substitution is 2 to the power of m squared will be a, 2 to the power of n squared will be b. Now, we know that k is odd, so that means k is of the form 2x plus 1. So that means that k minus 1 over 2 is x. And therefore, k minus 1 is equal to 2x. That's perfectly valid. And therefore, another type of term that I will need to figure out this whole expression involves k's, but let's just simplify this first, and then we'll make these substitutions. So we've got 2 to the power of m squared, all to the power of 4, right? I'm breaking it up. 2m squared over 2n squared times 2 to the power of 4. And on this side, we've got 2 to the power of k times 2 to the power of 4 plus 2 to the power of m squared to the power of 3 times 2 to the power of n squared times 2 to the power of k. All right, so now let's make our substitutions. This is going to be a to the power of 4 plus a times 2 to the power of 4, which is 16. So 16a over b, because this is b, right? Making my substitutions now. And then on this side equals 2 to the power of k times 2 to the power of 4. Well, that's just 16 times 2 to the power of k, like that. And then this one will be, we've got a to the power of 3 times b times 2 to the power of k. Okay, so far there's no tricks, it's just standard substitutions. Okay. And also, interestingly, I thought that we might need to use this substitutions, but we haven't. Okay, no problem. Now let's start to simplify. Let's get a common denominator here. So this is going to become a to the power of 4b plus 16a over b. And on this side here, I can factor out a 2 to the power of k, and when I do, I get 16 plus a to the power of 3b. And let's see here. I guess we can put this in the denominator over here. And when we do, we get a to the power of 4b plus 16a, and that will become 16b plus a to the power of 3b squared, and that's just equal to 2 to the power of k. Okay, great. So far, it looks pretty good. And factor out an a from the top, and that gives me a to the power of 3b plus 16. Factor out a b from the bottom, and I get 16 plus a to the power of 3b. And look at that. This is the same as this. 16 plus a to the power of 3 times b, 6a to the power of 3b plus 16. Okay, great. So all we're left with is just a over b is 2 to the power of k. So it turns out to have a very nice, simple result at the end. And that's very, very helpful. Now let's see what we can do with that. So at this point, we can go back and make our substitutions to further understand this. So a over b is equal to 2 to the power of k, and k is odd. Well, what's a? Well, we had called it 2m squared, and b was 2 to the n squared. That's 2 to the k. Well, that basically just means 2m squared minus n squared is equal to 2 to the k. Since the bases are the same, the exponents must be the same. So that means m squared minus n squared is equal to k. Wow, we are pretty much taking a monster right here and simplified it all the way down to just this right here. M squared minus n squared is equal to k. Now we can work with this. And another good thing about this question is there's no tricks so far. No algebraic tricks that needed to be used, just standard mathematics. Now at this point we have to start thinking, okay, it's great that we have it in this form, very helpful, but where do I proceed from here? And first of all, what is the question asking me? So let's backtrack and understand what is it that they want in this question. They want you to first understand that k has to be odd. So that's the first condition. Also, k is between 0 and 100. So those are the parameters. And then they want you to figure out which of these values of k, if you substitute it obviously into our very simplified equation, would give you two solutions for m and n. So the best way to explain that is with an example. So, for example, let's say k is equal to 15. First of all, let's see, does it satisfy my two rules? Is it odd? K equals 15 is indeed odd. And is it between 0 and 15? Well, of course it is. Now, we take our beautiful equation, substitute k equals 15. Well, that, as I'm sure you know, factors into m plus n, m minus n, like that. And now we've got a choice, right? Either this can be 15 and this can be 1, or this could be 5 and this could be 3. That's how you'd get two numbers to multiply to equal 15. Let's try both. M plus n is 15. M minus n is equal to 1. If I add these two, I get 2m is equal to 16. M is equal to 8. And therefore n, if I substitute that back into here, m would be 7. All right, great. So I got one solution for mn, 8, 7. Let's see. That was using these numbers. Now let's see what happens with those numbers. All right. With those numbers, m plus n would be 5. M minus n would be 3. Adding those, you get 2m is equal to 8. M therefore would be 4. So m equals 4 back into any of those original equations, it will give you n equals 1. So there we go. We got another one. mn is 4, 1. So for k equals 15, we got two solutions for mn. And that's exactly what they want you to figure out. For how many odd integers k between 0 and 100 does this equation, which we simplified greatly, have exactly two pairs of positive integers mn that are solutions? So it basically boils down to exactly what I did for k equals 15 for this very nice equation. Now you say, well, okay, that's great. I understand that completely. But here's the thing. There's a lot of numbers between 0 and 100 that are odd. There's 1, there's 3, there's 5, 7, right? All the odd numbers from 0 to 100, there's 50, I would imagine, right? There's no way I'm going to go through that for 50 numbers. You did it for 1, k equals 15. Do I really have to do that for 50 numbers on a math contest? There's no way. And the good news is you don't have to do it the long way. There's a shortcut, and here is the shortcut. What I did here is something that needs to be done for every single scenario that works. And what I basically did was I broke up k into its factorization, right? Either 1 times 15 or 3 times 5. And there was two of them. Here's 1, here's 2. Each of them gave me a solution. So that's the general rule, that we need to break up k into two factorizations. Each one will produce one solution for mn. And that is the general rule. So I have to see, how do I do that for values of k? And we are going to have three scenarios, three cases. Case number 1 is basically when k is of the form p times q, where p and q are prime numbers. And that will help us tremendously. And one example of that is actually what I just did, 15. If you notice, k in this case would have been equal to 3 times 5. And what that does is allow you to come up with two factorizations. The first one is just 1 times the number, so 1 times pq, which I had done here, 1 times 15. The second factorization would be p times q, like that, which is this one, 3 times 5. And each of these will produce one mn. So this will give me two solutions. All right, now I got to figure out what values of k satisfied this scenario. All right, well, the good news is that we don't have that big of a range. And since P and Q must be prime, we can sort of skip over a lot of numbers. So I don't really want to bore you to death and talk you through it, but 3 times 5, 15, that's one of them. 3 times 7, that's another one. 3 times 11, right? You just have to come up with combinations where both P and Q are prime and that the final number is between 0 and 100. And there's only a finite number. 3 times 13, I'm doing all the 3's now. 3 times 17, and you notice I'm only using prime numbers. 3 times 19, 3 times 23, 3 times 29, and 3 times 31. At that point, we start getting numbers that are greater than 100, and we don't want that because our range is between 0 and 100. All right, so this was what, 15, 21, 33, 39, 51, 57. These are values of K, by the way. 69, 87, and 93. Okay. Now I've exhausted the 3's. Now let's see multiples of 5. 5 times 7, 5 times 11, 5 times 13, 5 times 17, and 5 times 19. And I think after that we'll get over 100. So this is what, 35, 55, 65, 85, and 95. Okay, let's see how many more we can get. How about 7's now? I've exhausted the 5's. My next prime number is 7. 7 times 11, 7 times 13, and I think that's it to stay within my range. Okay, these are the only ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got 16 values of K for which this will work. Okay, put that here. Now let's see, is 16 one of the answers? 16 is not one of the answers, and that's probably a good thing, because otherwise you'd probably circle it and move on, because that basically means there's a few more. Okay, scenario number 2. This scenario was with K equal to PQ. Now things get a little bit more complicated. K could be of the form P to the power of 3. If it is, our 2 prime factors, or our 2 factorizations, a better way of explaining it, will be 1 times P to the power of 3, or P times P squared. Okay? Now we got to figure out which values of K satisfy that. Well, P can only be 3, because if you use 5, it would be 125, and that would become outside of our range. So P equal to 3 is the only one. So 27, that's my only value of K that will satisfy this condition. All right, well, that 27 gives me one more. And there's only one other scenario. That is when K is equal to P to the power of 4. That will give me factorizations as follows: either 1 times P to the power of 4, or P squared times P squared. That would be another factorization. And the only value that will work for P to the 4, again, is 3 for the value of P. That will be obviously 81, because if you put any other prime number, it becomes outside of that range for K. And that gives me one more value, namely 81. And there we go. We've got 16 here, we got 1 here, and 1 here. The total will be 16 plus 1 plus 1, which is 18. 18 is the answer to this very challenging question. And that means for number 25, the answer is D.